Hello, everyone. Today, our group presents you a poster on imperative programming. Definition of computer paradigm. A computing paradigm refers to a fundamental approach or model for performing computation, organizing data, designing systems of higher levels, and solving problems using computers. Importance of computing paradigms. Computing paradigms are crucial as they influence how problems are understood and solved. They determine the techniques and tools available to programmers and shape the development, maintenance, and scalability of software systems. Our group chose imperative programming. Imperative programming is a programming paradigm in which the program is composed of a sequence of explicit instructions or commands. Programmers write a series of commands that the computer executes in a specific order, with each command modifying the computer state. This paradigm is chosen for its straightforwardness and intuitiveness, making it easier for programmers to understand the execution flow and debug the code. Imperative programming is highly efficient for real-time and interactive applications due to its focus on control flow and state change. Next, introduction to imperative programming. Imperative programming is a paradigm based on a sequence of steps or statements that modify the state of the program at each step. It focuses on performers specifying a series of commands executed sequentially, each changing the program state until the desired result is achieved. In this approach, the computer receives and processes these commands step by step to reach the final outcome. Both procedural and object-oriented programming language, such as C, C++, C#, and Java, fall under the umbrella of imperative programming. Then, timeline of imperative programming evolution. 1490s, early foundations. Assembly language, the earliest form of imperative programming, using symbolic code directly translates to machine instructions. 1950s, high-level languages. Fortran, Argo. 1970s, structured programming. C combined low-level memory manipulation with high-level constructs, becoming a foundation for system and application programming. 1980s, evolution and integration. Pascal. 1990s, modern languages. C++, extended C with object-oriented features, bridging imperative and object-oriented paradigms. Python provided simplicity and readability, making imperative programming more accessible. JavaScript 1995 brought imperative programming to web development, becoming essential for intelligent websites.
Imperative programming can be visualized as an sequence of operations, where each step depends on this provides one. Here is a simplified representation. Initialization, define and initialize variables, set in the programming states, execution, sequentially executes a series of commands. Use control structure such as loops and conditioners to manage the flow of execution. Perform operations that modify the state of the program. Termination. Programming research and end states output the final results of a state. Feature 1. This diagram shows the high records structure of the imperative programming paradigm, including sequence, constraints, procedure, object-oriented, and parallel processing paradigm. It ensures how different sub-paradigms fall under the broad category of imperative programming. Which 2. This diagram highlights the nested nature of imperative programming, shows how procedure and structured programming are subsets within the larger imperative programming paradigm. It helps to understand the various relationships along these concepts.
Essential characteristics of imperative programming. Set of this, the program operates through a series of states, where each state represents a specific configuration of the program's variable and control flow, called by its benefits. By explicitly managing states, programmers can precisely control the execution flow and debug the program effectively. Each state transition is clear, make it easier to understand how the program progresses. Sequential execution commands are executed one after another in a specific order, called by its benefit. This predictability specifies the reasoning about the program's behavior, as the flow of execution is straightforward and easy to follow. Control structures include loops for while, conditions now, if else, and case statements that dictate the program's control flow. Code by benefits. These structures enable complex decision-making and interactive process within the program, allowing for more sophisticated and dynamic behavior. Variable manipulation. Variables store data that can be modified through assignment statement, called by the benefits. Direct manipulation of variables allows for process control over data and state changes, which is essential for tasks that require fine-grained control, such as system programming. Procedural abstraction. Function and procedural group related common into reusable units, killed by the benefits. This modularity promotes code reuse and better organization, making larger programs more manageable and reducing redundancy.
Functional programming is better than object-oriented programming. It avoids side effects by using poor functions and immutable data structures, making programs more predictable and easier to test. It can avoid the program of race conditions caused by state sharing in concurrent programming. It encourages the use of higher-order functions and combinations, and code in this mode tends to be more concise and expressive. I like this style because it makes code more elegant and concise.
I prefer to use imperative programming because it is straightforward and simple. Imperative programming uses explicit instructions to change the state of program, and this style of programming is ideal for beginners. Also, object-oriented and functional programming have many advanced features. Imperative programming is more efficient in many cases. In embedded system with limited hardware resource, imperative programming can provide better performance and lower resource consumptions.
Object-oriented program is my first choice because it is a perfect for team developer. In OP, the concept of class and objects allow team members to work on different models and collaborate with each other during development. This improves development effective and makes the code easier to manage and maintain. Design pattern help us solve command design programs and improve the quality and maintainability of our code. OP is based on real-world objects and relationships, which makes the requirements analysis and the design process more intuitive and